day, I'm Julian Garcia, a third-year student taking up BSECE, and this video is my video reviewer for differential equations. Before I proceed with my first-order differential equation application, I would like to give you guys a short recap of what a first-order differential equation is. According to the website college.cengage.com, the definition of a first-order differential equation is that it is in the form where p and q are continuous functions of x. This first-order differential equation is said to be in the standard form. Basically, there are four types of differential equation applications, namely growth and population, Newton's law of cooling, chemical solutions, and lastly, electrical circuits. So the problem that I'll be discussing with you is under the category of growth and population. Basically, when a population of cells multiply in a culture dish, the rate of growth in the population at any instant is proportional to the size of the population itself at that time. We call this exponential growth. Putting this description into mathematical terms, we write the population size at time t as p of t, then the derivative of p with respect to t is the rate of growth of the population p at time t. And this is given by this equation below here, and where k is a constant of proportionality. So going back to the problem that I constructed, at January 13, Jenny was diagnosed to have a stage 3 cancer of the liver. Her doctor told her that the cancer cells are rapidly increasing, that in 2 weeks' time, the cancer will reach stage 4, having 25,000 cancer cells in her body. A total of 5,000 cancer cells were detected during her stage 3. Unfortunately, after 3 weeks, Jenny died with a total of n number of cells in her body. Find an expression for the number of cancer cells in t weeks and determine the total number of cancer cells in her body when she died. So this is Jenny during her stage 3 diagnosis, having 5,000 cancer cells in her body. Her doctor told her that the cancer cells are rapidly increasing, that in 2 weeks' time the cancer will reach stage 4, having 25,000 cancer cells in her body. We take the equation of the rate of growth in the population at any instant is proportional to the size of the population itself at that time. So here, we isolate dn over n and k equals to k dt. Integrating both sides, so the integral of dn over n equals to the integral of k dt, we get the equation ln of n equals to kt plus c. Of course, to simplify it further, we multiply it by e, having the equation n is equivalent to the exponential value of kt plus c. Bringing down c1, we get n is equal to c1 multiplied to e raised to kt. So going to our problem, we just plug in the values at t equals to 0. So at t equals to 0, n is equal to 5,000. Plugging it in, 5,000 equals to c sub 1 multiplied to e raised to k times 0. Having this and solving this, we get 5,000 equals to c sub 1. So for us to be able to solve for the expression for the number of cells in T weeks, let us first proceed to T equals to 2. So at T equals to 2, we have N as 25,000. Plugging it in and the earlier value of C1, we get the equation 25,000 equals to or equal to 5,000 multiplied to e raised to k times 2. Simplifying both sides or dividing both sides by 5,000, we get 5 equals to e raised to k multiplied to 2. So for us to be able to solve for k, what we do is we multiply it again by ln, having ln of 5 divided by 2. So after that, we get the value of k, which is equivalent to 0.805. And so voila! We found an expression for the number of cells in T weeks. Having n is equivalent to 5,000 times e raised to 0.805 times t. So here we are at the last question. So at t is equivalent to 3 weeks, we have to find the number of cancer cells there in the body. Plugging in all of the values that we solved earlier, like C1 is equivalent to 5,000 and K as 0.805, we'll be able to get the number of cancer cells in her body when she died, which is equivalent to 55,948.85 cells. Or we could estimate it as 55,949 cancer cells. So for our final answers, for letter A, n is equivalent to 5,000 multiplied to e raised to 0.805t, while at letter B, n is equal to 55,949 cancer cells. So that's it. Basically, that's just it. So thank you for watching my short video reviewer. Hope to see you again soon. Bye-bye.